So our next step in this case study is mapping the components. This is perhaps the most important step in the architecture process. In this step, we map the various components or services in the system and define for each one its role, communication method, and API. We've talked a lot about this step earlier in this course, and as you probably remember, we said more than once that once the mapping is done, it's not easy to go back. We basically define how the system is going to look like for the duration of its operation. This means we should take this step very seriously and be very cautious about the decisions we make here. Now, the first question we need to ask ourselves is how to perform this mapping. What is the criteria we will use when deciding about the scope of the services? Well, to do that, let's go back to the microservices attributes we've discussed earlier in this course. As you might remember, we talked about 9 attributes mentioned in Martin Fowler's article that define a good microservices architecture. So if you will take a look at these attributes, will that help us decide on the mapping? Well, it looks like it is. Microservices attribute number 2 states that microservices are organized around business capabilities. This means we should check whether we can find business capabilities that are autonomous and make each one of them a service. Now, we have well-defined entities in this system. We talked about books, customers, borrowings, etc. And this is something we can use when mapping the services. So, let's try and design the services around them. In other words, let's see if you can use the business entities as the boundaries for our microservices. This approach of designing services around business entities is one of the most common design approaches, and it's usually a successful one. So that's another reason for trying this approach. So what are the business entities we have in the system? Well, it looks like we have 3 major entities: books, borrowing, and customers. But that's not all. In addition to the business entities, we have 3 more system-wide utilities we already know we will need and which are not part of the business entities. These utilities are notifications, payments, and view, which is the component that displays the user interface in the browser. Now, I want you to note that for the sake of simplicity, we will not discuss logging and monitoring. Although extremely important, I want this case study to focus on the functional mapping of services, and we have already covered all aspects of logging and monitoring in the respective section, so I leave it out of this one. So we have 3 business entities and 3 cross-system utilities. So it looks like we have 3 services in the system. And now, let's deep dive into each one of them and see how it looks like. And the first one is the books service. So what is this service? The books service is used to manage the books inventory in the library. Using this service, we can add, modify, and remove books from the library. Every new book purchased by the library is going to be added using this service. Note that the service has nothing to do with customers borrowing the books. This is the responsibility of other service. This one only manages the books the library holds. This service is going to be used by the librarians. The librarians decide which books to add and which to remove. Now, naturally, this service has a storage. It needs to store the book details somewhere and requires its own storage or database. This service should be synchronous. This means the service should provide immediate response for its actions. A librarian added a book, she should know immediately the book was successfully added. Also, when removing a book, we should know immediately the book was removed from the list. The synchronicity of a service plays an important role in the service's API design, as we will see in a minute. Lastly, this service does not depend on other services. We don't need other services for this service to operate successfully. This makes our decision to design this service around the book's business entity to look more logical, since the autonomy of services is one of the key factors in microservices architecture. Okay, so this is the book service. And after defining its functionality and scope, we need to discuss another important aspect of it, which is its API. As we've talked earlier in this course, the services API is perhaps the most important part of the services design because it dictates how other services are going to communicate with it. And inter-service communication is something that's going to happen a lot in microservices-based system. Now, if you remember, one of the key factors in deciding which kind of API we are going to use is the nature of communication with the service, whether it's synchronous or asynchronous. Now, in this service, we are going to use REST API, which is the most popular type of web API. And we will do that because we need an immediate response from the service, which makes this service synchronous. Now, what do we need from the API? What is the functionality exposed by the service? Well, let's look at the main functionalities of this service. We need to get book details by book identifier. We, of course, need to add new book, remove book, and update book. These are all quite common functionalities of a business entity service. Now, part of the architect's work when designing services is to actually design the API, and this is what we are going to do now. So, this is the API of the service. As we mentioned, we are going to use REST API, which exposes 4 actions, and so we have 4 endpoints in this API. Let's go through these endpoints. The first one is for getting book details. The endpoint uses the get verb, which is what we should use for retrieving data. The URL is API v1 book and the book ID to retrieve. This endpoint can return one of 2 response codes, 200, which is OK, and 404, when the book specified is not found in the system. Now, if you're not sure why does the URL looks like this and what are these response codes, I've covered this extensively in my REST API design course, and I highly recommend you to take it. It contains all the best practices for designing professional REST API, and it will help you along the road. Anyway, this is the first endpoint. The second one is for adding new book. Here we will use the post verb, which is used for adding entities. The URL is API v1 book, and we expect the body of the API to contain the details about the new book. The expected response code from this API is 200 OK. The third endpoint is for updating an existing book and thus uses the put verb, which is used for updating entity. The URL is API v1 book and the book ID to be updated. Note, this is exactly the same as the Getting Book Details API, and these endpoints vary only by their verb. This is generally a sign of a good design. Here also, we expect the book details to be updated to be provided in the body of the request. The response codes here can be 200 OK or 404 not found if the book specified is not found in the system. The last endpoint is for removing book from the list, and it naturally uses the delete verb. The URL looks the same, API v1 book and book ID, and the response codes can be 200 OK when the book was removed, and 404 not found if the book to be removed is not found. Okay, so this is the API for the books service, and that concludes the first service. And now let's move on to the next service. And the next service is the borrowing service. This service is used to manage the borrowing of books. So when a customer borrows a book from the library or returns a book to the library, this is recorded by this service. This service has many similarities with the books service. It is also used by the librarians. It has a storage to store the data about the borrowings and returns. It also should be synchronous because the librarians using it expect to get immediate feedback, and it does not depend on other services, although it does refer to books managed by the books service and the customers managed by the customer service, which we didn't talk about yet. Now note that even though this service refers to data managed outside of its scope, we can still say it does not depend on the other services. The definition of depend in this context is quite simple. Will the service continue working if it will be the only operational service in the system? And the answer here is yes, because the service does not call other services. It just uses identifiers that can be used in other services databases, but its operation does not depend on it. And what about its API? Well, here also we are going to use REST API for the same reasons. We need immediate response from the service since it's a synchronous service, and the REST API is a great fit for that. the API should expose the following functionality: add a borrowing, add a book return, and get borrowing by customer, so we can see what books were borrowed by a specific customer. So after defining that, we can see the actual API. And you can see again the use of the get verb for getting data about borrowing by customer, and the two posts, one for adding new borrowing and one for adding a return. Note also the return codes, where the get might return 404 to indicate the customer was not found, and the other ones are expected to return only 200. So that was the borrowing service, which, as we said, is quite similar to the books service, which brings us to the next service, the customers service. And the customers service is also quite similar to the last two services. It is used to manage the library's customers, is used by the librarians. It too has a storage to store the data about the customers. It needs to be synchronous, so the librarians using it will get immediate feedback. And it too does not depend on other services, although it refers to books and borrowings stored in another services. And we explained before why this still makes this service independent. And what about its API? Again, the same story. We will use REST API because we need immediate response. And the main functionalities exposed by the service are adding a customer, removing a customer, retrieving customers' details, and retrieving the list of books borrowed by a customer. These are the main functionalities exposed by the service. And this is how the API looks like. So you are probably already familiar with the general structure of the API, so I won't go over it again. But I do want to point out the second API's structure, the one used to get the customer's borrowed books. As you can see, the API looks like that. API v1 customer, customer ID, books. The books at the end of the URL is called sub-entity, and it appears after the customer ID because it indicates the books of a specific customer. When we construct an API that retrieves entities which belong to other entities, these entities, the sub-entities, will always appear after the identifier of the main entity. So in this case, the main entity is customer, and the sub-entity is the customer's books, and so it appears in this order. This is a best practice you should always follow when designing REST API. Okay, so that was the customer's service, which brings us to the next service, the notifications service. The notification service is quite different from the services we've discussed so far. It is used to send notifications to the library's customers. For example, when a specific book was returned, or when an interesting book was added to the library, and so on. Now, one of the special things about this service is that it is used by other services and not by human users. For example, the books service might call this service when a new book is added, or the borrowing service might use it when a book is returned. And what this means is that we can make this service asynchronous. The services calling it do not expect immediate response. They want to instruct it to send notification in its earliest convenience, and that's it. They don't stand there waiting for a response saying, "Success, I've sent a notification to 10,000 users." Another important aspect of this service is that it might experience load. Sending notification to all the library's customers will result in a huge amount of notifications sent, and we must be able to handle this load. So how do we do that? Using a well thought of API. In contrast to the other services, we are going to use queue as a communication channel to this service. Queue should be used when no immediate response is required, which is exactly the case with this service. And one of the great side effects of using queue is that it distributes load. Using queue, messages to be handled can be pushed to the queue and wait there until someone on the other end, in our case the notification service, can handle them. And so there is no load on the service, but it pulls messages to handle when it can. So queue is the perfect candidate for this service. Our next service is the payments service. This service is used to send payment instructions to external payment service. Note this service does not do the charging, but it routes it to other external third-party mechanism. The reason is that handling payments is an extremely delicate and painful process, and whenever possible, we would prefer outsourcing it to external systems. So this service sends payment instructions to the external system. Similar to the notification service, this service is used by other services. For example, when a new customer joins the library, he should be charged the annual fee. So the customer service calls this service for that. That makes this service asynchronous too. And another important aspect of it, it must be very reliable. We are talking money here, and this service cannot stop working when needed. So let's see how do we deal with it. And again, we will do it using the API. We are going to use Q again for this service. As we said before, when no immediate response required, Q is the perfect candidate. But there is more. Most modern queue engines offer built-in high availability, so that solves our high reliability problem. Using queue, we can ensure that even if the service is down, the payment instructions are still safely stored in the queue, waiting to be processed. And that brings us to the last service, the view service. This service's only goal is to serve static content to the web browser, namely HTML, CSS, and JavaScript files. This is the service the browser will call when first entering the system, and after getting the static content, most of the work will be done with the other user-facing services, the books, borrowing, and customers services. This is an extremely basic service, which really contains no logic, almost no code, has no special considerations. It's basically a glorified file share. As such, no API is required for this service, as it works directly with the browser. Okay, so we are done with the services mapping of the system. As you can see, we have ended up with 6 services. Each is clearly defined, autonomous, and has clear communication channels. And now, let's conclude it all.